Okay, so here's the assembled product. I've assembled all the components onto a piece of Vero board or prototyping board. This isn't being used, this is just mounted permanently to my Arduino testbed. I've got it connected directly to the RGB light, and I've added the two buttons. So this is the default setting when you turn it on, which is the digital sequence. So that's going to go red and green together, green on its own, green and blue together, blue on its own, and then white. Ish. So if I click to the next program, this is now the analog version, so the transitions will be more gradual. And what we can do now is use this button to speed it up. So that's reduced to 2.5 seconds per step, and I'll drop it down a couple, then you can see it. So that's 1/3 of a second between steps. And you can see there's a really pleasing transition. And then if we go to the other programs, so it occasionally jumps because I'm introducing a voltage from my fingers. So that's green on its own, that's blue on its own. That's red on its own, green on its own, blue on its own, and then back to the sequencer again. So that's the very fastest setting. It's a bit crazy, and then when I click it again it goes back to 5 seconds interval. It's personal choice, but I prefer it on 2.5 seconds interval. And I think you can get some quite pleasing effects with this, but it's a proof of concept as much as anything. The idea is for you to experiment with the code and design your own lighting sequences. I'm going to assemble this shortly onto the back of my television because this is self-adhesive strip, and you can also cut it. It's got a break every 6 or 7, yeah, every 6 LEDs I think it is, or every 3. Yes, every 3 after the first one. So you can literally snap this, and then I'm going to make 4 lengths to go around the TV, and then I have to solder them all together, which will take quite a bit of doing, and then that will project onto my back wall. If I don't hit the camera too much, that will project onto my back wall and just provide a very pleasant ambient light. So that's the RGB LED controller programmer project, and you can do pretty much anything you like with it. I have found you can get an Arduino case, which you might be able to fit this in with a small enough hat on. This is not very tidy, but it was such a job to get the components to sit level because of there being 3 power transistors underneath. So I'll just show you how that works when it's finished. This pin goes to pin 11. The spacing on the connectors is different on that side. And there they are, those are 3 power transistors. These are the 2 10k resistors to pull down the switches, and then 3 100 ohm resistors feeding the base on each transistor. The emitters are all connected together with the black wires, and the RGB, red, green and blue wires are the outputs, with white being the common positive 12 volts which comes in on this connector. So it's important that we earth the negative on the 12 volts coming in to the pin on the Arduino, otherwise you're going to have problems. So the 0 volts on the Arduino, the ground pin down here is connected to this black wire, which is connected to the emitter on all the transistors. If you don't do that, there's a danger that when you switch the LEDs on, it's going to pass large current back into the Arduino and destroy it. And as you can see, my orange wire has fell off again because it's such miserable thin wire, but that's usually attached back onto there to trigger the blue channel. Anyway, thanks for watching, and I hope this has been some use.